Hello pre-calculus students, and welcome to the video on writing logistic functions. And we're going to do this example here where it's asking us to write a logistic function with specific requirements. And just a reminder, this is what a logistic function looks like. There's basically three variables that we need to look for: C, A, and K. And C is called the limit to growth. Okay, so let's look at here. It says, write a logistic function that satisfies the following requirement. The initial value is 10, the limit to growth is 40. So when I see limit to growth, we know that this is C. C equals 40. So now this says that the function is f of x equals 40 over 1 plus a e to the negative kx. Okay. Then we're going to use the next bit of information here, which is the initial value. And the initial value here is the starting point, so we know that f of 0 equals 10. Okay. So then I can substitute that into the function, and I can put 10 in here for f of x, and just put 0 in for the value of x. So this is 40 over 1 plus a e, and we're putting in 0 here for x, so the entire statement here is going to be 0. This then gives us that 10 equals 40 over 1 plus a. And then we just solve this equation. So we get 10 times 1 plus a equals 40. 1 plus a equals 4, dividing both sides by 10. And finally, a equals 3. So now I know the function is f of x equals 40 over 1 plus 3 e to the negative kx. And the one thing that remains for me to do is to find the value of k. So now I'm going to use this point here. Passes through 120. So that means f of 1 is equal to 20. So I'm going to substitute this in. 20 equals 40 over 1 plus 3e to the negative k times 1. And we're going to solve this equation to get k. So this is not an easy equation to solve, but we can certainly do it. Multiply both sides by the denominator here. Divide both sides by 20. Left and right side is equal to 2. Subtract 1. Divided by 3. And now to really finally get the value for k, if you're not familiar with logarithms yet, then you're just going to have to graph this to get the value for k. So I'm going to use my graphing calculator here. I'm going to say e to the negative x really represents k in this case, is equal to 1 over 3. Whoops. Okay. Not a great picture, so I'm just going to zoom in a little bit. Second calc, find the intersection. So k is about 1.0986. So I know A, I know C, and now I know K. So that means my final answer is that f of x is equal to 40 over 1 plus 3, so that's A, times e to the negative 1.0986 x. And again, this function is somewhat approximate because this number here is an approximation, the value for k, but we do know that this is roughly what it's equal to. So this is a logistic function that meets all of these requirements. Now at this point in the video and in our series of videos here, this is somewhat of a mysterious function here. We'll see in future videos why the logistic function is very useful, and it's particularly useful in dealing with population questions, and especially population of humans. Thank you for watching. Have a wonderful day.